G'day guys, and welcome back to Up to Speed with Elasticsearch. We are up to chapter 5, so officially halfway through the course, and big thanks to anybody who's followed along all the way through until now. Please do stick around until the end. In this chapter we're going to be looking at, as you can see, mutations. So in the last couple of videos we've been looking a lot at ways to search Elasticsearch, getting data out of Elasticsearch. In this video, we're going to be looking at getting data into Elasticsearch and making changes to that data once it's already in Elasticsearch. Before I get into that though, I wanted to quickly look at a homework exercise that I gave you at the end of the last video. We noticed that sorting results in the Shakespeare index by speech number was producing a strange sort order, so I wanted to take you through my solution for that. So just to go over the problem again, if I do a search on the term king and I sort the results in descending order by speech number, we can see the first speech number that we get is 9, which is already kind of strange because 9 is a very small number. Then it goes down to 8, and then we notice 74. So 8 is certainly not larger than 74, but if you've ever sorted an array of numbers stored in strings, you'll have noticed something similar to this, where it does a string comparison based off of the first character. So 8 is larger than 7, hence why it appears this way. So if I do a quick retrieval of the Shakespeare index, you'd be able to see why. If we scroll down to speech number, it is actually indexed as a keyword. Now, on your index, you probably won't have this guy here unless you came to the same solution as I did, but this is basically my solution to the problem. So we had indexed speech number as a keyword type. And keywords, as we've said, are great for exact match searches. You can also do stuff like wildcard searches on keywords, and you can sort by keywords, but it is going to be an alphabetical sort, not a numeric sort. So what I did was to add a numeric subfield to speech number. By the way, you can add this subfield to the index without creating a whole new version of the index, because you can update the mapping of an index in place without creating a whole new index, so long as you're adding new mappings and not removing mappings or changing a mapping from one type to another. You cannot do that. If that's what you want to do, you do need to move to a new version of the index and re-index all your data. But if you're just adding a new field, including a subfield, you can do that in place. So that's what I've done. I've just added a numeric subfield, which is of type integer. And what you then may need to do is to run an update by query. That's basically because we've added this new field, but all of the existing documents in the index haven't had this new field populated yet. So it's going to be kind of blank for them, and you'll get stuff returned to you in a very strange sort order. So if you run this update by query, what it will do is it will update every document in the index, but we haven't actually specified anything to update. So no changes are actually going to get made. It's just going to populate this new field that we've added. So that is an important step to not forget. And at the end of it, we can then sort by speech number dot numeric, and if we run this again, we should get stuff sorted in the right, sorted correctly. So speech number starts at 155, looks much more promising than 9, 144, 74, 66, 62, 50. All right, that's looking much better. So congrats if you were able to solve that, particularly with this update by query, which we haven't covered yet. We are actually going to cover this shortly in this video. Yeah, and with that done, I think let's move on to the actual contents mutations. So we have basically just a bunch of tasks for this video. There's going to be no more theory, at least that I can think of right now. Certainly not for this video. So yeah, let's just do a couple of these hands-on tasks and see how things work. So our first task is to create a new movies index. So this is going to store our favorite movies, should be in green health, support the following fields: movie ID, name, genre, stars, and it should have dynamic mapping disabled. So if you want to pause here and give this a try by yourself, just because we've done this a few times, you're more than welcome to. As always, I'm just going to copy this so I don't forget what I'm doing. All right, so we want a movies index. So I'm going to say put movies. I'm probably not going to be updating it, but I'll still version it and call it v1. We want this to have an alias of movies. We want this to have a mappings dynamic. Dynamic is going to be set to strict. We want settings, which will have replicas set to 0 and shards set to 1. So 1 primary shard, 0 replicas. The other properties that we're after is going to be movie underscore ID, which is going to be type integer. Where are we? The name is going to be type, let's see, movie name. We could index this in two ways. We could index this as both text, but also have a keyword subfield. Type is going to be keyword. That way we can support both full text search and simple exact match search and ordering and things like that. Okay, what else do we want? So that's the name. We could add a genre. I think genre can just be keyword. And stars can be an integer. You know what? Integer might even be too high. Is there like a byte? Yeah. Okay, let's give that a go. So I think we can go ahead and run this. Cool, awesome, and let's retrieve it. Movies. Great. Okay, looking good. So that's our first task done. Actually, let's just confirm we are in green health. Great. Next task is to actually start adding data to this. So first things first, we want to add one movie to the index, and we want to use one of the following genres. So let's copy this. Let's do a put movies doc. Let's just use 1 for the document ID. Let's use, hold on a second, I've forgotten what it looks like. So we have genre, movie ID. Genre is going to be action. Movie ID, I'm just going to reuse 1. What else? Name, let's see, an action movie, Die Hard. And stars, I have to give this a 5. Okay, so let's go ahead and insert this. Awesome. And if I do a quick search, an empty search, we should get back Die Hard. Nice. Okay. So what we could do next is add 9 more movies to the index. This approach that we used here is great for adding a single document, but if you want to add multiple documents, you probably will want to use a different approach, and the approach that we can use is a bulk insert. Bulk API, that sounds good. The syntax is a little funky, so I'm just going to copy paste this, and then yeah, we can work with this. So let's see, the index that we want to work with here is, well, as you could see, you can perform different types of operations in the same query, but for us, I think index is fine. The index that we want to use here is movies. The ID here will be 2. I think if we don't provide the ID, it should be able to auto-generate it. Let's actually leave that out and see what happens. So we want the genre to be, let's see, let's go with fantasy this time. And the movie underscore ID can be 2. Let's see, the name can be Lord of the Rings, the Lord of the Rings, and stars, I'll give it another 5, and this is going to be another index operation. So the index is going to be movies, and the genre is going to be, let's see, let's go with sci-fi this time, and the movie ID will be 3, and the name will be Star Wars. And I'm also going to give this a rating of 5. Can I do one more? I may do one more just so that we have one document per genre. A horror film, Nightmare on Elm Street, and I'm not a big fan of horror, so I'm going to give this a 3. And if I run this, we can see that 3 documents got created. If I rerun my search, we can see we've got Die Hard, Lord of the Rings, Star Wars, and Nightmare on Elm Street. Cool. So that works quite well for adding multiple movies or adding multiple documents in the same go. There is a limit to this. If I remember correctly, it was something like a 10 meg payload or something to that effect. So there is a theoretical limit to how much data you can send at one time, but it is quite generous. Okay, so that's ingesting. Of course, I'd encourage you guys to add more, just so that you've got a little bit more of a realistic index to play with. But for myself, I think I'm going to stop here. For updating, we want to change the genre on one of the movies by re-indexing the document. So what I might do here is actually look at a partial update. Where is it? Index APIs, it could be under here. Where are we? Could actually be under documents, document APIs. Update. There we go. And there should be an option here for partial. There we go. So what we want to do here is change the genre on one of the movies by reindexing it, but I don't really want to have to resupply the entire document body. So let me just grab actually all of these three, and I'll get rid of these. Okay, so let's just do a quick search. And let's say I want to change Die Hard from an action movie to a Christmas movie. So I know that the ID of Die Hard is 1. Let's go ahead and say, I'm just going to copy this. There we go. So the index is going to be movies. 1 is coincidentally the ID of Die Hard. And I want the genre to be Christmas. Let's run this, and if I run that same search again, where are we? We can see Die Hard is now a Christmas movie, and yeah, that works well. I actually really like Star Wars. I'm a huge fan, so I actually want Star Wars to break the rule here and not be a 5-star film. I want it to be a 6-star film. So that's what I'm going to do for the second task here. And what we're going to use to perform this is we'll use a scripted update. So using the same or similar method, we're going to update the document, but we're going to use a script. So we can copy this snippet here. The index that we're going to be using is the movies index. 1 is not the ID of Star Wars. The ID of Star Wars is this lovely guy here. We probably could have set up the IDs to be a little bit better. All right, I think that's all fine. I just want to say, let's get rid of this. Okay, I should probably point out one thing before I continue. So ElasticSearch has a scripting language that we're using right now. The language name is Painless. I think way back in the day, they used to use another language, Groovy. Painless, I believe, is an ElasticSearch invention to basically replace Groovy, so you only really use it inside of Elasticsearch. Syntactically, though, I'd say it's kind of a mix of JavaScript and Java. So whenever you're dealing with scripts in Elasticsearch, you typically will have this CTX variable available to you, which is some kind of a context. If you're after like the actual document that the script is running on, that's usually available to you in an _source child property under the context, and then you have access to the fields on the document. So at the moment we're after stars, and we want to increment it. So I should be able to say ctx._source.stars++, and this will do an atomic increment on the stars of Star Wars. So if I run this, we get updated, and if I run the search again, we should see Star Wars down the bottom, which has now 6 stars. So that's quite nice. This is certainly better than doing something like a read the document, increase the stars by 1, and then write the document back, because if you have multiple updates running at the same time, you could end up with an incorrect count. So this is a much more concurrency safe way to do that. All right, and lucky last, at least as far as updates are concerned, we want to update all movies in the index so that all sci-fi movies are moved to science fiction, which is again going to be Star Wars, but let's just pretend we've got more sci-fi movies other than Star Wars. So the operation that we're going to use here is an update by query. And how this works is kind of similar to a search and an update together. So we are going to be running a kind of a script like this, but we are also going to be specifying a query like we normally use with search, and that's how we can perform like a batch update. So I'm just going to run a post on movies / update by query, and the query is going to be where the genre, let's see, I'm going to use a term query here. The field is going to be genre, and the value is going to be sci-fi. I always think whenever you're doing an update by query, it's often a good idea to run a search first. And just test that your query is correct before running it. Kind of like do a select before you do an update or a delete. So let's run this. We do get back sci-fi. We do get back Star Wars, so that's great. Pretty confident with my query. Next is going to be my script. So my script is going to be ctx._source.genre is equal to, let's change this to science fiction. And let's run this. We get one document was updated, which makes sense. If I run the search again, I should get actually no matches. But if I change this to science fiction, there's our Star Wars film. So those are a few different common ways that you could update documents in Elasticsearch. And lucky last, I think we're going to move on to deletions. So we've got two tasks for deleting movies or deleting documents. Explicitly delete the 10th movie. I actually don't have 10 movies. I kind of took a shortcut, but I'll just run a search on movies, and I'll delete the last one. No, not Star Wars. All right, let's just go ahead and do that. So if you have a specific document that you want to delete, you can delete it using the delete verb, the name of the index, or alias _doc _doc / the ID of the document. So this should delete Star Wars, and if I run my search again, we can see we've got Lord of the Rings, Nightmare on Elm Street, and Die Hard. No more Star Wars. Bum, bum, bum. All right, so next is we want to delete all horror movies. So right now we only have one, but let's just pretend that's not the case. Let's pretend there were many horror movies in this index. Similar to the update by query operation that you also have a delete by query that you could use. So it works in a very similar way. So what we're going to do is let's just prepare our query. Our query is going to be a term query where the genre is horror. We get back one record, great. And what we can do now is we can run a post movies delete by query, and the query, well, I think I can just copy this body. I think it's the post HTTP verb, but we'll soon find out if I'm wrong. Awesome, so we've got one deleted document, and if I run this search again, we get no documents. If I run the search without any body, we can see we've got Lord of the Rings and we've got Die Hard. No more Star Wars because we deleted it explicitly, and no more Nightmare on Elm Street because we deleted it using the delete by query. So these are, I suppose, the two only real ways that I've used to perform deletions. There is actually one or two other ways that you can do it. You can specify different operation types when you run an update by query. So you can actually delete using an update by query, but I think this is probably enough to get you guys going for now. And I think that actually wraps us up for this video. So there wasn't really a lot of theory to cover there, just a bunch of different practical ways of mutating data in Elasticsearch. So I think I'll wrap up here, and I'll see you in the next video where we look at ingest pipelines. Thanks a lot. See you later. Bye.